Hello, geometry students. Welcome to another lesson in area. We are talking about composite figures today. We're in section 10-8, and what I would like for you to be able to do by the end of this lesson is to be able to find the area of composite shapes by applying formulas and identifying the pieces of a composite figure. So what we got going on here is we have shapes that are very abnormal because they have multiple pieces put together to form one shape. So we're going to have to break it up into its subparts and then either add or subtract in order to find the total. So in example 1, it says find the shaded area by adding, round to the nearest tenth if necessary. So first of all, let's look at the two parts of this that we have. We have a half circle and then we have a trapezoid. So I'm going to write half circle plus trapezoid. That's what we're going to need to do to figure out the whole area. Now let's write the formulas for each of those. So the formula for the area of a circle is pi r squared. So to figure out half of that, you would just take half pi r squared. So I'm going to say 1/2 pi r squared for this one. And then we're going to say plus, and then the area of a trapezoid is 1/2 height times base 1 plus base 2. All right, now it's time for us to start substituting these values in. First of all, let's start with this semicircle. This 22 millimeters is the distance all the way across. The distance all the way across is the diameter. So if I want to find the radius, I just need half of that. So the radius would be considered 10. So I'm going to take a 10 and put that in for the r. So now I have 1/2 times pi times 10 squared. And then I'm going to take that, that's 1 unit, plus the stuff for the trapezoid. For the trapezoid, I still have the 1/2, and what's the height? Well, the height is 14. From this point to this point is the height of the trapezoid portion of it. And notice it is perpendicular to the base, so that's how I know it's the height, so I'm going to say 14. And now I'm going to consider the two bases. Well, the bases are the parallel sides, remember, so this is a base, and this is a base. I'm not going to say base 1 is 10 because that would only be half of it. Base 1 is the whole distance across 20. I only made it a 10 over here because I needed radius in that one. So for base 1 plus base 2, that's going to be 20 plus 32. And now it's time for us to start finding the areas of each individually and then adding them together. So this one is going to be 1/2 times pi times 100. And when you put that into your calculator, we get 0.5 times pi times 100. And that is getting me 157.1. Okay. So this simplified down to that. Now let's figure out what this is. This is 1/2 times 14 times 20 plus 32. I'm doing that first because of order of operations. That's going to be 52. So 1/2 times 14 times 52 is getting me 364. So this is the area of the half circle. This is the area of the trapezoid. I'll label that for you real fast. So this right here is the half circle. This right here is the trapezoid. So if I want to find the total area between the two, add them up, and that's what our answer will be. So I have 157.1 plus 364. Add those up. I'm just using my trusty calculator to do that, and I'm getting 521.1, and then I'm going to put my unit on there, millimeters squared. And there you have it. So in this example, I had two pieces stuck together to get me a larger new shape. In example 2, though, it's a little bit different because now we have a shape within a shape and it's being removed. So I'm actually going to darken this shading a little bit so you can see what we're actually trying to calculate. We're trying to calculate the shaded region of this. So just doing some quick shading here real fast. All right, so that's what we're trying to calculate. It says find the shaded area by subtracting, round to the nearest tenth if necessary. So what we're going to need to do this time, we're going to need to find the area of the whole circle and then subtract the area of the trapezoid from that. So I'm going to find the area of the circle and then subtract the area of the trapezoid from that. So the area of a circle, the formula is pi r squared. So I'm going to write my formula out, pi r squared minus, and then the formula for the trapezoid, that is 1/2 height, base 1 plus base 2. Okay, now let's substitute our values in. For the circle, I need r. Right now, this 20 is going all the way across. So to figure out what r is, I just need half of it, so the radius would be 10 in this situation as well. So I have pi times 10 squared minus, okay, now I'm going to do all of this stuff. So I have 1/2. What is the height of this trapezoid? The height is the vertical distance from the base to the base. So that is what this 8 is representing right here. So I have 8 for the height, and then I need the two bases. Well, the bases are parallel to each other, like I said. So this 12 and that 20 are the two bases. So I'm going to say 12 plus 20. Now it's time for me to start simplifying each of these individually using order of operations. So this becomes pi times 100 minus, and this is becoming 1/2 times 8 times 32. Pi times 100 is equal to about 314.2, roughly. I'm just rounding right there. When I take 1/2 times 8 times 32, I get 128. And I just put that into your calculator. So I got 0.5 times 8 times 32. That's how I get this 128. Now I'm taking the circle, which is what this value is. This is the circle area. And this is the trapezoid area. And I'm going to subtract the two of them. And when I do that, I'm just going to put that straight into my calculator. So 314.2 minus 128. And that is getting me 186.2. So I've got 186.2 centimeters squared is what the area of the shaded region in this is. All right, take that page and flip it over. We are going to do number 3 together in class. So skip down to example 4. Now this one will be kind of quick and easy for us. It says use a composite figure to estimate the area. The grid has squares with side lengths of 1 centimeter. So I'll just label that real fast. This is 1 centimeter and this is 1 centimeter. Now, because we have this grid, it can be, pretty simple for us. Right off the bat, we're just going to start breaking this down into pieces that we can easily calculate. So right here, we have this square. That square is very easy to know the area of. It is 4. So right off the bat, I have 4 for an area. So I've got 4, and then I'm going to add some more to it. Now we can focus in, let's say, on this triangle down here. Well, I could say, oh, this triangle, like this half and this half could come together to form a whole square. So this half right here would form 1 square unit. So I'm going to say plus 1. So both of those are 1 together. Then I could do the very same thing for these two right here. I could say, oh, okay, this one and this one come together like this half. Let's pretend that I could move this half down here into there. Now remember, we're estimating. So no, this is not exact, but it's a rough estimate. So these two could come together and form 1 square centimeter as well. So now I'm going to say plus 1 again. Then I have this guy. And this is about half and half also. So this one's plus 1. And then I've got this one. This one's a little bit weird. It's not quite as exact. I think because it's an estimate, you could probably go in a couple directions. I'm going to estimate low personally. So I'm going to say, yes, I know, like if this were actually down here, then these two would form a better 1 unit. So I know we have a little bit of surplus, but I can't estimate how much that really is. I can take an eyeball amount, but I don't really know what it is. So I'm going to say these 2 units right here are approximately 1 as well. So I basically had a rectangle or a square in the middle, and then I had 4 triangles on the outside that I considered for the area of that shape. Now I add all those up. So 4 plus 1 plus 1 plus 1 plus 1 is getting me an approximate area. So area is approximately 8 centimeters squared. So this, we were just using the grid to kind of aid us. That's not an exact answer, of course, but just from eyeballing. All right. The last example 5 we're also going to do in class. So that's all I have for notes for you guys in this video. Please have a great night.